Welcome all to this session on the lab programs of Analysis and Design of Algorithms. Myself, Madhu Nagraj, Assistant Professor, Department of CSE Data Science, ATME College of Engineering, Mysore. Today, I am going to explain the first lab program, that is, design and implement the C program to find minimum cost spanning tree of a given connected undirected graph using Kruskal's algorithm. So, before finding of the minimum cost spanning tree using the Kruskal algorithm, let's first see what is a Kruskal algorithm. A Kruskal algorithm was discovered by a graduate student called as Joseph Kruskal. In this algorithm, always the minimum cost edge has to be selected. But whenever we are selecting it, it is not necessary that the edge which is selected, it is always the optimum edge which is adjacent. In this algorithm, we will first sort the edges of the graph based on their weights. That is, starting from the edge which is having the lowest weight or the minimum cost will be selected first, and then it continues as and when the weight increases. So first we are going to sort the edges based on their weight. So the edge with the minimum weight is added to the empty tree, and then among all the remaining list, the next smallest edge will be considered and it will be added into this new existing tree only if the addition of this edge will not create any of the cycle. That is, if at all by adding this edge, it forms a cycle in the new tree, then that edge will be just discarded and we are going to select the next edge which is having the minimum cost. So this procedure will be continued till the tree which is having all the vertices or all the edges are spanned or it is visited. And once it is completed, then all the edges will be visited and we are going to stop the spanning or stop this algorithm. Since we are selecting the edges based on the minimum cost, which is an optimal solution, hence this algorithm is also called as a greedy algorithm. So now let's just see how this Kruskal's algorithm work based on an example. So here I'm having an example which you can see on the screen. So this is a graph where we have to apply the Kruskal's algorithm in order to construct a minimum cost spanning tree. So here you can see we have the edge BE which is having the minimum cost of 1. So as I told, so the first step is to sort the edges based on their weight. So first, here you can see the edge which is having the minimum cost is BE. So that is taken first. Next edge is AB which is having the weight 2. Next AD which is having the weight 3. CF also is having the weight 3. BF is 4, EG 4, DE 5, GF is 6, DG is 7 and FC is 9. So based on this weight, so we have considered the edges. That is, we have sorted the edges based on their weight. So starting from the minimum weight till it reaches the end of the tree. So we have added all the edges. So next step is constructing the spanning tree. So first we are going to consider the first edge which is having the minimum cost, that is BE1. Next is AB. So it is added to the spanning tree AB. Next we have the edge, that is AD. So AD is added. So as we can see here, by adding of all three edges, none of the edge is forming a cycle. So it is being added into the spanning tree. Next edge, it is CF. So when we add CF, so it is also added into the spanning tree since it is also not creating any of the cycle. Next edge is BF. So BF is added. So from starting from B, so BF is added. Next is EG. EG is added here. Next GF. So when we add GF, so when we add GF edge, so there will be a cycle form. So GF is not added and it is discarded. Next DE. So when we add DE, again a cycle will be formed. So that edge is also discarded. Next DG. So if we add DG, so there also we get an edge. So we will get a cycle. So that edge is also discarded. And last edge, so FC, which is already added. So FG will form a cycle. So that is why it is not added. So here you can see, so this is the minimum spanning tree which is formed from the graph which we have seen at the starting. So this is the graph and this is the minimum cost spanning tree which is formed from the graph. So what will be the total cost? So the total cost will be 3 plus 2 plus 1 plus 4 and 3. So this is the minimum cost which is formed by from the graph given. So that is the example which we have considered. So this is the steps which we have discussed, that is sorting the edges, then picking the smallest edge and then repeating the steps until all the edges are considered. Now let's see how this algorithm can be implemented using the C program. So now I am shifting into the IDE, that is the code blocks, to execute this program. Here you can see the program, the C program, which is used to implement the Kruskal's algorithm. Starting with, I'm added the required header files, that is stereo.h and standardlib.h. Next, I've declared the variables which is required for providing the indices or the index, and then the number of edges and number of vertices. The minimum cost I've assigned to 0, and then the cost matrix we have taken and the parent matrix we have considered. Next, we have two functions, find and union. So starting with the main function. So first, we are asking the user to enter the number of vertices. So based on the number of vertices, the user will next enter the adjacency matrix. So starting from 1 to the number of vertices. So the loop will run that many number of times and then the cost matrix has been scanned and it has been entered. So here, whenever the cost matrix value is 0, so we are assigning that value as 999. That means, so if there is no edge and the value is provided as 0 in the cost matrix, so we are converting it into, or we are assigning the value 999 for that particular value. Next, so this while loop will be running how many number of times means, so this is the number of edges. NE means the number of edges, N means the number of vertices. So here initially N is assigned to 1. So the number of times this will run means, that is N minus 1 number of times. That is, if I have 5 edges, then this loop will run for 4 times. If it is having 8 edges, 8 vertices, then it will run for 7 times, like that. So the while loop will run for n minus 1 number of times. So starting from 1 till n, so the loop will be running, the for loop. Then we are going to check the cost matrix if cost of ij is less than minimum. That is, if the value which is we are checking, so it is less than minimum, then that matrix will be assigned to value minimum. Then A is equal to U equal to I and B is equal to V is equal to J. So here we are taking two values U and I because if at all we want to check for the index values, then again we need not go and check it back. So directly we can assign it to I and we can consider it when we are finding the index of that particular node. So that is why we are assigning for both the variables UI and Vj for A and B. Next, we are calling the function find of U. So what happens in the find function? So in the find function, we are going to find the parent of that particular edge, that particular vertex. So here we are checking whether the edges or the vertex belongs to the same parent or not. So if they belong to the same parent, then in the union function, we are going to just ignore it. That is, if the parent are equal, that means it will form a cycle. So it will not be added into the spanning tree. So if the parent is not equal, that is I is not equal to j, then what we are going to do? So we are assigning it into that particular tree and we are adding that node into the new spanning tree. So if it is equal, that is if I is equal to j, then we are just returning the value 0. That means we are not adding that edge into the spanning tree. So here, once find u and find v functions are completed, that is after finding whether they are belonging to the same parent or not, then we are checking the union condition. That is, if union of uv, that is, if it is done, that is, if the union function is called for u and v and it has been added to the spanning tree, then we are going to print the edges. That is percentage d edge, percentage d, percentage d, that is which is the minimum edge that we are going to add into the spanning tree will be printed with the help of this print statement. Then we are going to calculate the minimum cost. So the minimum cost is calculated by the formula minimum cost equal to minimum cost plus minimum. So each time the cost will be added with the minimum value. And then if at all the cost of AB is equal to cost of BA is 0, then we are going to add the value 999. Then finally we are going to print the minimum cost of the spanning tree. So now let's execute this program and see the output. So here I am providing the number of vertices as 5. So enter the cost adjacency matrix. I am entering the cost adjacency matrix. 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1, 1. So we are getting the minimum cost spanning tree. So let's see one more example with another graph. Number of vertices, I am providing it as 5. So enter the cost adjacency matrix 0, 8, 5, 0, 0, 8, 0, 9, 11, 0, 5, 9, 0, 15, 10, 0, 11, 15, 0, 7, 0, 0, 10, 7, 0. So here you can see the edges of the minimum cost spanning tree are the first edge is 1, 3, which is having the cost 5. So this is 1, 3. Next we have 4, 5. So 4, 5, which is having the minimum edge of 7. Next 1, 2, having the cost 8. And then 3, 5, which is having the weight 10. So here you can see, so this is a spanning tree which is formed with the minimum cost in the increasing order and also the spanning tree where it does not form any of the cycle. And finally, we are getting the minimum cost which is equal to 30. So this is how we are going to implement the Kruskal's algorithm using the C language. Thank you.